Hello everyone, I'm Kerem Elmacı. I'm a molecular biology and genetics student on my second year and fourth term, and here's my Physics 102 project. So the name of my project is Galvanometer and Parallel Plates Observation on a Changing Capacitance Experiment. The aim of my experiment is to understand the basic concept of capacitance and to see how changing the distance and the dielectric constants throughout the experiment would actually change the capacitance. And also, another objective is that I want to see the usage of galvanometer in the measurement of current. Before I begin talking about my experiment, I want to briefly mention theoretical concepts behind the components of my experiment. A capacitor is an electrical circuit component with two terminus points that has the ability of energy storage in the form of an electric charge. So there are just two electrical conductors separated by a distance, and this distance can be filled with nothing, the vacuum, or alternative an insulator called a dielectric material. In this experiment, air, wood, and glass are observed as the material in between. The formula most important to my experiment is as shown in the figure. So the capacitance is dielectric constant times permeability of air to electricity times surface area of the parallel plates over the distance between them. The galvanometer is an electrical circuit component that, thanks to its magnetic torque movement, very accurately measures the current. However, since the resources I had access to could not make up for a galvanometer attached circuit with capacitors, I could not include it in the practical components and the data I have prepared. Okay, so let's move on to the experiment. So my experimental setup consists of connecting cable sets, a parallel plate capacitor, a capacitance meter, a galvanometer, a multimeter, a scientific calculator, glass dielectric creating a 0.4 centimeters of distance between the parallel plates, a wooden dielectric creating a 0.6 centimeters of that distance, and a ruler. After taking correct measurements of the parallel plate capacitor, the first part of my experiment was initiated. So the first part consists of the changing of the distance and seeing the relationship between distance and capacitance. So I made varying distances between the parallel plates and then wrote down the capacitance according to capacitance meter, and then I included them in my data. For the second part of my experiment, I considered the effects of dielectric constant on capacitance. Therefore, since before there was nothing and just air between the parallel plates, now I added wood and then a piece of glass between the parallel plates and then wrote down the capacitance accordingly. Here's the graph that I obtained that shows the capacitance is decreasing when distance between the parallel plates are increasing. The data obtained from this experiment is as shown. The average of the percentage error in the first part of the experiment is approximately 600%. Furthermore, the dielectric constant I found for glass is smaller than expected. It is theorized that the most likely error source is the lack of precision within the system. The capacitance meter used gave small values within its nanofarad system. With picofarad measuring devices, investigated capacitance values could be measured much more precisely. In addition to device errors, other small errors might have occurred, such as human eye errors when measuring the distances, or the influence of other electrical devices.